Okay, page 21. Okay, people enter a line for an escalator at a rate modeled by the function given by R of t. Where R of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time t equals 0. So part A, how many people enter the line for the escalator during the time interval from 0 to 300? So we know that this is the rate at which we're entering the line. So if we want to find out the total number of people, we can just take the antiderivative. Again, numbers 1 and 2 are calculator active. So we're just setting up using, make the calculator do the work for us. I just want to show you that R of t is people per second, time is in seconds. So if I multiply people per second per second, I end up with number of people. So anytime you take the antiderivative, you're always changing the units because you're always multiplying by a time or your x component. Okay, part B. During the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? So we know this is a rate in, rate out problem. So there's always this formula that we can apply, right? The total people in line is the initial plus the number of people entering minus the number of people who've exited. So we have the rate at which people are entering. We got the rate at which people are exiting. Then initial is the number of people at time t equals 0. So here's the formula that will get us the number of people at any moment in time. So I built my equation first, and then I used the equation to help me find 300. So at 300 seconds, how many people are in line? I got 20 plus 270, but then 210 people have exited. So there's 8 people. For part B. So it's like that rate in, rate out problem where if I have the rate at which people are entering, then the antiderivative is going to tell me the total number of people who've entered into the line. Right. Because if I have the rate, let's say my rate is 5 people per minute, then if I were to take the integral, then it'll tell me 5 times 4, which is 20. So
20 people.
Right. But this is an ever-changing rate, so we're just going to make the calculator find that number for us. So we have a general formula that will tell us, whether the number of people in line at 5 seconds, at 10 seconds, at 20 seconds, but I'm giving that flexibility so that I can have that upper bound t to be any p value that I want to look for. So whether I want to look for the number of people who entered in the first 5 seconds, or entered in the first 20 seconds, or in the first 60 seconds, I can just plug into my formula. And my R of x, I got to use this formula here, right? So I got to plug all this in the calculator. This is a mess, but I got to plug all this in the calculator. All right, so if the integral of this is going to tell us the number of people up to that point in time. Because if I just plug in 300 into this, it'll just tell me the rate. It won't tell me the number of people that I'm looking for. Same thing here. 0.7 is also a rate. The integral from 0 to t of 0.7 will give us the number of people. So then we just plug 300 in for the upper bound. Enter all this in the calculator, you'll get 270. Enter this in the calculator, you'll get 210. Right, part C, after 300 seconds, what's the first time that there are no people in line for the escalator? So after 300 seconds, there's no more people in line. So basically, we just have to figure out how long will it take for these 80 people to exit the escalator. Okay, so we know that the exit rate is 0.7 person per second. So we know that this 80 people is going to at a rate of 0.7 times t. So that means if I divide both sides by 0.7, it'll take 114 seconds after 300 seconds in order for those 80 people to clear out. So the 300 plus 114 will give us 442. Part D, between 0 and 300 seconds, at what time t is the number of people in line at a minimum? So that's an indication that we want to apply EVT, extreme value theorem. So extreme value theorem says, start with your equation, find the derivative, set the derivative equal to 0, find your critical points. Once you find your critical points, then you're going to test your critical points and your endpoints against your P of t equation and see which one produces the smallest value. So here's our P of t equation. I want to find the derivative, so I can find the slope, set equal to 0, find critical points. 20 goes to what? What's the derivative of 20? 0. What's the derivative of this integral of r of x? Just for r of t. What's the derivative of this integral of 0.7? Just 0.7. Okay. Because if I take the derivative of the integral, this wipes out, I'm just left with 0.7. Right? Because 0.7, the integral of 0.7 is sitting at a level above 0.7. I think the derivative of the integral, that's going to wipe out. The only thing left is 0.7. So there's my p prime. So I want to figure out where is p prime equal to 0. So I set r of t minus 0.7 equal to 0. Graph this equation. Find the t values. Now you're going to have to adjust your window because you're looking for t values between 0 and 300. So you have to sketch this graph, but then also adjust your window. So you may have to go to your window and adjust your x min, x max from 0 to 300, just so that you can see the full extent of your x-intercepts. And then once you find these values, then you know you're testing your endpoints and your critical points. They all get inserted into the P of t equation, and you compare the values. Right? Smallest value will be your minimum. So I just want to kind of go over the highlights of the problems, but hopefully you guys have time to go through and test these out and actually plug in the calculator and actually find these values. Yeah. So, you take this, you take the R of t equation, minus 0.7, you plug it in the calculator, and then you graph it. And then once you graph it, you're looking for the x-intercepts, and one of the x-intercepts is gonna be, yeah, and the other one's gonna be 166. Okay, number two. I think you'll find number two pretty straightforward here. Particle moves along the x-axis, velocity is given by v of t. Particle is at position x equals -5 at time t equals 0. Find the acceleration. So acceleration is the derivative of velocity, so you make the calculator find the derivative for you. So you do math 8 and derive velocity at 3, and then make the calculator give you back the derivative at the point, which is acceleration, which is -2.118.
So you just do the derivative.
Yeah, and derive, yeah, math 8 and derive velocity 3, and it gives you that acceleration value. Okay, find the position of the particle. So if I have my initial position and my velocity, I know I can go through my position equals initial plus displacement. So I'm looking for a position at 3. I have my starting position at 0. I want to figure out how much progress I made between 0 and 5. So the calculator can help us get that displacement. -5 plus 3.24. And then -1.76. Um. You're right. It should be from 0 to. 0 to 3. Let me double check that. Because I want to start at 0 and go to 3, right? Let me double check, make sure that's right. Yeah, sorry. The answer is, this is right, but my bound should be from 0 to 3, because I'm starting at time 0. I'm ending at time 3. So I need to figure out that distance in time from 0 to 3. Evaluate the definite integral from 0 to 3.5 of v of t, and then evaluate the definite integral from 0 to 3.5 as the value of v of t. The difference here is one is displacement and the other is distance, total distance. So displacement is just the change in position. So wherever you start, wherever you end up is how much progress you made either in the forward or the negative direction. Total distance is counting if there's any direction change, everything is turned into a positive. So if I go to the right 4 units, left 2 units, right 5 units, it's adding the 4 plus 2 plus 5. But displacement is just how much net gain did you make. So if your distance and your displacement are the same value, what does that tell you about this particle's motion? It doesn't change direction. But if the distance is a different value, and if this is different, it's always going to be larger. That means there's a change in direction somewhere along that path. Or somewhere along that journey. Part D, a second particle moves along the x-axis, got a different position function, t squared minus t. At what time are the two particles moving with the same velocity? So let's find the velocity function for x of 2, and then we can just set them equal to each other and see at what times do they share the same velocity. So my second particle's velocity function is 2t minus 1. My first velocity is this 10 sine over t squared minus 2. This is tough to solve, so we make the calculator do it for us. I can either graph these two equations and look for the x-intercept, which may be difficult to find, or I can bring everything over to one side, graph this long expression, and then just look for the x-intercept. That's another way to do it. Okay. We have the graph of continuous function g. G is the derivative of function f. So we can also call this f prime. Function g is the piecewise linear from -5 to -3, so to 3. And then g is going to pick up with the parabola. And we have f prime at our disposal, so I have an initial position, displacement, I can find at -5. Careful though, we're starting at 1 because that's what they give us, but we're going backwards. So initially you got to set up with your starting at 1 and you're ending at -5. So it's backwards, but this is how you want to set up at the beginning. And then if you want to flip the bounds, you can change the sign so that you can read the graph from left to right. But make sure you start off with the lower bound matching your starting position, your upper bound feeding your end time. Okay, so now that this negative is out here, I've adjusted to my change. You go from -1 to 5. look at that area between the graph and the x-axis. All of this is going to be nice geometric shapes. You may see other shapes here, but you're only looking at what's between the graph and the x-axis. Okay, anything else is not part of what you're looking for. So I got square there, -9, triangle -3/2, triangle 1, square 4. Part B, evaluate the depth interval from 1 to 6 of g of x dx. So we're essentially finding the area under the graph between 1 and 6. But there's a change, right? Up to 3, we have nice geometric shapes. But then from 3 to 6, we have the curve. So this side, we can just add up the triangles and squares. But this side, we got to go through antiderivative power rule. So we reach the same goal, but with a different setup. From 1 to 3, you can just add up the geometric shapes. From 3 to 6, we got to go through this process. Either you go through substitution, or you expand everything out and go through power rule. This is a non-calculator, so we got to work this out by hand. Whether you expand it out or you go through your substitution, you're going to end up with 6, and then 4 plus 6 equals 10. Okay, part C says, on what interval is the graph both increasing and concave up? Okay, you're looking at the derivative graph here. So increasing and concave up means increasing has to be above the x-axis. Concave up would have to be positive slope. Right? Positive slope on the f prime graph indicates increasing graph. So it's got to be above the x-axis, then it's got to be positive slope. So we have this region here, this interval here, this interval here. The next part is saying, is there a point of inflection? Point of inflection will be the peaks and valleys. The only peak and valley that I see is at 4. Okay, number 4. Give you guys a minute here. Depends what are you doing.
Yeah.
That's fine, yeah. But make sure you do name your function. So if you say graph or it, right, you want to name like f double prime or f prime. But yeah, abbreviation is fine. Just make sure you name whatever graph you're referring to. Okay. Okay. Height of a tree is given as a twice differentiable function. So again, smooth curve all the way through. No sudden unexpected surprises in these order pairs here. In these order pairs. Use data to estimate h prime of 6. Well, I have h. I want to estimate h prime. I know h prime is the rate of change, so slope. Pick the closest order pairs. Change in height over change in years. Part B explained why there must be at least one time where h prime is equal to 2. I know I can't do IVT because I don't have any h prime values. I know h prime is the slope of h. So if I want to guarantee a slope, I got to use the mean value theorem. So if they gave you 2 and 10 to begin with, go ahead and find the slopes. See if you can determine what the slope is. So because whatever the slope is I get between 2 and 10, I know the graph is going to actually reach that specifics, that rate of change somewhere along the path. So by mean value theorem, since my h of t is continuous and differentiable, I didn't state that, but I should have. The slope between 3 and 5 is 2. So I know there must be at least one time between 2 and 10 where the rate of change of the tree is exactly 2 meters per year. Part C, trapezoid sum. So identify each of your widths. Oh, first, sorry. Part C, use trapezoid sum with 4 subintervals to approximate the average height. So average height, we've got to go through average value theorem. So
not only do we do the integral from 2 to 10, we also need to do divided by 1 over b minus a, or multiply by 1/8.
So 1/2 width, height 1 plus height 2 for every trapezoid.
And the width you can find by subtracting the t values. 3 minus 2, 5 minus 3, 10 minus 5, 10 minus 7. But when you get to the heights, make sure you don't subtract them, that you're adding them. 1.5 plus 2, 2 plus 6, 6 plus 11, 11 plus 15. Now, this is non-calculator, so you can leave your answer unsimplified. You don't have to go all the way down. Right, so, yeah, I encourage you guys to leave your answer unsimplified, because first, if you're already sitting at the right answer, why spend more time on it? And second, if you made a mistake adding and subtracting, you're going to get points off. So might as well just leave your answer unsimplified so you don't lose any potential points. Okay, part D. The height of a tree is modeled by another function, g of x, where x is the diameter of the base in meters. When the tree is 50 meters tall, the diameter of the base is increasing at a rate of 0.03 meters per year. Notice that there's time components here. So, and then also it says, what is the rate of change of the height of the tree with respect to time? So that's a clear indication that we're trying to apply what? Related rates. Yeah, so that means we got to build the derivative with time component in mind. We got to attach a d over dt for every variable that we see. So we're going to first build the derivative here. G equals 100x over 100 plus x. We got to go through quotient rule. dg dt will show up. dx dt will show up. And then once we build the derivative, then we can start putting information in. So g equals 100x over 100 over 1 plus x. G becomes dg dt. Then we do quotient rule, f prime g minus f g prime all over g squared. dx dt is 0.03. Defines the g value at when g is 50, we can work backwards with the original equations to figure out what x is. And once we have the x value, we can plug that in as well. Oh, are you talking about this f prime here?
Yeah.
So the derivative of 100x is just 100. But then x will produce a dx dt. Right. But we are asking for x's derivative though. Right. It's just like if we do implicit differentiation, for instance, let's say I had 3x squared plus 2y minus 4x equals 1. Implicit, we got to do something special with y, right? So 6x plus 2, y becomes 1, but we need to attach a dy dx because we're taking y's derivative. Right. So here we're taking x's derivative with respect to time. So x is going to turn into a dx dt. Right. Normally we don't do this usually for x's, but because x is not the independent variable, time is the independent variable. So time is going to affect that variable x. Now, if there was no x to begin with, then you're right, there will be no dx dt. But we are asking for x's derivative, so x's derivative is 1 times dx. Just like if I ask you for implicit, 2y will become 2 dy dx. Even though the y disappears, there's still a leftover from that derivative that we need to keep track of.
Okay, any questions with D?
Okay, we have e to the x cosine of x. Find the average rate of change. So average rate of change is just the slope between the endpoints. So f of pi minus f of 0 over pi minus 0. We find the ordered pairs at 0 and pi. We just do change in y over change in x. Students take US history, or do you know what grade students usually take US history? AP, A push.
Junior year.
Junior year. Is anyone not going to be here tomorrow because of? Okay. I'll address that deal.
Think a lot of people. I know, like,
Okay, for part B, find the slope. So to find slope, we have to first get to the derivative. From the derivative, we can then plug in 3 pi over 2. So go to product rule, f prime g plus f g prime. And then you have to resolve your trig values. You can't leave your answer as cosine 3 pi over 2 minus sine 3 pi over 2. You got to show that to the graders that you understand that, how to resolve those values. Okay, so sine pi over 3 pi over 2, you got to say -1. Cosine 3 pi over 2, you got to say 0. You can leave your answer unsimplified after that, but any trig values, you got to show that you know how to get them.
Part C, find the absolute minimum. So again, extreme value theorem. So extreme value theorem, you have to set f prime equal to 0, find your critical points, and then test them against your f of x and see which one produces the smallest value. So a lot of trick here. You set f prime equal to 0, e to the x is never going to be equal to 0. Cosine minus sine, the trick to handling this is setting them equal to each other, dividing both sides by cosine, and then you can see tangent of x equals 1. And then you clearly see, oh, it's pi over 4 to pi over 4, first and third column. So you enter 0, pi over 4, pi over 4, and 2 pi into the original function, and you compare the y values. Whichever has the lowest y value is the absolute minimum. Okay, part D. Find the value of the limit as x approaches pi over 2. So anytime I see a limit problem, I'm thinking maybe they're trying to get me to use L'Hopital's rule, but we got to first confirm that. So first thing you do is evaluate your limits, plug in pi over 2 and for all the x's. I made this key before I realized that they were really picky about the equal sign. So make sure you use arrows for all your L'Hopital rule steps. Don't try not to use any equal sign. So I evaluated my points. I get 0 for 0. That tells me I can do L'Hopital rule. So f prime is the derivative that I found. G prime is the slope of the, this is G prime. So put the order pair here. G prime of 2 is just 2 here. But they tell us G of pi over 2 is 0. So that's how it goes 0 over 0. G prime, to look at the graph here. So I have f prime of 2 over G prime of pi over 2. And I'm able to get down to a real number after initially getting that 0 over 0. Okay, number 6 is just slope fields and tangent equation and solving differential equation. I think you guys can handle that. Tomorrow we'll go through the 2017 FRQs. And well, maybe I'll pick some problems between 2017 and 2016. I have some optional things for you to pick up. You don't have to pick these up, but I just want to tell you what I have available. One is packet 7. These are just a mixture of miscellaneous and secondary topics that I didn't really spend a whole lot of time in class doing because to me they're kind of minor, but these problems have shown up before in the past. So I have a packet of that along with the key. You want to pick that up only if you have time.
to, if you're still working through this packet, if you don't think you finish this by Sunday, then just focus on this. I don't want you to spend any time on this if this is really, if you have additional time. I have a video for that. I have it under Sunday, so I'll make sure that you know where to find it if you want to see the video of me walking through that packet. I also have packet number 8. Packet number 8 is going to be a set of last minute FRQs that you haven't seen. These are from alternate versions that College Board created in recent years. So I'll spend Sunday evening on Teams going over that. I also have the key attached to it if you want to work through it ahead of time. And then I also have a sheet with unit circle values for you to practice with and just last minute reminders that I found on the website somewhere. So you can pick this up today or tomorrow, or you don't pick it up at all. Not more great. Don't get your phones.
Like this is hard. I mean, I don't know if you're being. I think it's not.
Yeah.
It's okay. What?
You're gonna go to sleep.
Especially for it. Where you said that. I didn't see yours like USB. Yours is weren't that bad, but I'm not.
Right, because
Yeah. Yeah.
because the number of people in line is built from my PFT equation. Because if I just use the integral of.
Like I understood how to get it. I understood why we used it here.
But okay, so the reason that we gotta do P prime here and not just the integral of this, or not just the integral of that, is because we're talking about for part D, right? It's because we also have to take into account, the people who are leaving. Because the people who are in line are impacted by those people entering, but then also the people who are leaving. So if we don't include both of these parts, then we're not getting the true number of people. Or the rate of people are.
Yeah.
So for this one, the graph, for question D, it says find each x and then function.
This is
Oh,
P is F prime. This is
right, this is the direct set. So I'm finding, okay, so point of inflection from there. So that is just saying where it changes direction.
yeah, where the slope changes.
Why would, like, let's say like right here where this goes, let's just stop it.
So this is a plateau. It's not a peak. So so we don't consider that a peak or valley. It's gotta be a max or min. It's gotta be just one point. It can't be a flat line.
So like,
So that's not.
just the fact that this goes increases and decreases.
Right, yeah, but because there's all the set, it's not just one number. Yeah,
Right.
that's not considered.
So that's what you're doing.
That's not, yeah, exactly.
Like, I understand what you're saying. Yeah, you're saying.
Right. It's gotta be kind of like a
At
hill.
one point.
Yeah, it's gotta look like a hill or a valley.
So for question number B,
Mhm.
using
Absolutely. Yeah.
Like, we don't know what that one is. How many you want to make? First one, can you do that?
no, for question, yeah, B, not trapezoid. B, so for mean value
And like the
theorem.
first one.
How did you know? Because didn't you say to use the endpoints?
Yes,
That's where I got confused. Because.
Exactly.
Because then you use the 35.
Yeah, that's what they will.
2 and 1.5.
That will probably be.
Oh, it's 15.
The
Yeah,
first, like,
15 versus 5. That's what I did, I think.
Well, you used 3 and 5.
Oh, I
which is where
did.
got confused because I was like, I didn't even use those. I just understand.
Mm-hmm.
Yeah, 3 and 5.
Okay, this is a little mean here because if they give you the endpoints, they're usually asking for you to just test the slope between the endpoints. But it didn't quite give me 2. So I had to go and test other order pairs as well to see if any of the order pairs will produce a slope of 2. That's kind of mean. Usually the problems are pretty nice where they give you they give you the endpoints, and then those endpoints is leading you to the slope that you're after. This is more rare where you have to kind of go searching for order pairs that will produce that slope, and that takes longer.
Okay, so and then for C, I got confused because isn't this already at the, so isn't this H of T already at the,
It is. It is.
the f of x level?
It is. So,
Why is it taking it back up? 'Cause
So-
then up or down again.
well, it bumps it up. Right, it bumps it up. But you're right, it bumps it up, but then it's gonna bump back down when we divide by time. So, you're right, H of T, you take the integral of H of T. You end up meter. So this unit is gonna end up being meter times,
Right,
which is weird. But then you're dividing by one over the thing, you're dividing by time again, and then you're back down to meters.
okay.
So that average value will bring you back down to your.
We know that because,
because they say, find the average value, find the average height.
okay,
So we gotta use average value theorem.
got it. So no, I feel is that like, so for number C, right, I understand. So I'm trying to get the. Right,
Well, you don't.
I don't understand,
Tangent.
like,
Mhm.
The one
I just need like a reminder,
Mhm.
because that was like my online year.
I didn't learn that much.
The tangent is just,
Okay,
okay, or in other words,
Right.
think of it this
I
way.
just need to know what to rememorize, right? Like.
So. Or just think of it this way. Where is cosine equal to sine? Well, if you think about all your unit circle values, where is cosine equal to sine? That'd be, you don't necessarily,
Middle one?
yeah, exactly, just that middle one, which is power 4. So you don't have to go through the tangent if you don't want. Just think about unit circle value. When are these equal? They're equal at power 4. They're also equal at 7 power 6.
Okay, so you just looked at when they're equal to this. But then, can you just give me a
Yeah.
refresher on what?
So, tangents is. So let's say it has cosine equals sine, divide both sides by cosine. So tangent is equal to sine over cosine. That's the relationship. And you know how
And like,
every order pair is x comma y.
Right.
Tangent is
now, I don't
Y
know
over X.
those little, so like, you know. Tangent is Y over X.
so any,
So like, I don't
Inner
have
circle
those
values.
memorized, where like 1/2 divided by, you know what I'm saying?
Right.
Like, would you say that's something I should definitely memorize?
yes, but I don't even have it fully memorized either. This is how I do it. I go through this little trick here. Says the most important thing are these 3 order pairs, right? So what I do is I start at the upper left corner. Then I go 1, 2, 3.
Well, yeah, I have that memorized.
Okay,
I just don't have like their divided answers memorized in my head. Like I would have to solve it by hand.
like.
Like if I were to find,
Find the 7 pi/6, something like that.
no, I could figure
Okay,
that out,
okay,
I think.
okay.
I would,
Yeah,
try to visualize it, but I'm saying like if you told me to find a tangent of, 45 degrees,
Okay,
I
yeah.
wouldn't.
so, right, so, but this is all you need though to get to tangent, because tangent is just y/x. So y/x is just this divided by this. If I cover up the denominator, they're gonna cancel out, so √2/√2, which is √1. And then tangent of pi/3 is just √3/1. Tangent of pi/6 is just 1/√3.
Oh, wait. Oh, so you can just cover the denominator.
Yeah, just denominators just cancel
So
out.
it doesn't
right?
matter.
Doesn't matter.
Okay, I remember.
Yeah, okay, 1/√3 or √3/3, just depends on whatever form the problem asks you to give it.
Okay, I need to go to bio. Can you just bring me a pen? Thank you, I appreciate it.
Mhm.
Hoping it's starting with like. Oh, this is your pen.
I take that unit.
Mhm.
Yeah. Probably see you after school.
Okay, sounds good. All right.